Hi everybody! So today we're going to look at the standard form of a quadratic function. Our goal today is going to be able to make it in vertex form, and we want to be able to graph it, okay? It's pretty simple, we just got to find the vertex first, okay? So, the standard form is right here, y equals ax squared plus bx plus c, where a, b, and c are constants. Now, in vertex form, which you might remember is y equals a times x minus h squared plus k. You'll notice you had an a here as well. They're the same a, okay? The a in vertex form and the a in standard form are the same. There's a reason why we use the same letter, okay? A few things to note is you should pay attention to the signs of these three. That's very important, and let's try this out, all right? We want to rewrite the equation y equals x squared plus 4x plus 3 in vertex form, all right? And in order to do that, we know the a value, all right? Because right here, my a value is 1, right? There's that 1 in front of the x squared. But in order to get the vertex, I just have to use these steps over here, okay? We need to find the x value of the vertex using the equation h or x. I like to write x just because it's the x coordinate. So x equals negative b over 2a. Then we're going to substitute that value in for x to find the y coordinate of the vertex, or k. And then we can use the same a value because, as I told you, we use the same letter for a reason. So here, a is 1, b is 4, c is 3. You should get good at figuring that out, okay? So x equals negative b over 2a. So x equals negative 4 over 2 times 1. So negative 4 over 2. So x equals negative 2. Therefore, y equals negative 2 squared plus 4 times negative 2 plus 3. Oh, didn't mean to scroll. So y equals negative 2 squared. Negative 2 times negative 2 is 4. Be careful with that. Make sure that you don't accidentally do your order of operations wrong. Minus 8 plus 3. So it equals negative 4 plus 3, negative 1. So my vertex, therefore, is negative 2, negative 1. So in vertex form, it's y equals x plus 2 squared minus 1. Because remember, y equals a times x minus h squared plus k. Negative 2 minus negative 2 will make it plus 2. The a is 1, and then we have my minus 1 at the end. So there is my equation in vertex form. All right. Let's try this again. All right. So now I'm asking you to do one more thing. And you have two options for this, really. Graph the equation 3x squared minus 6x plus 1. Okay? Now we can either rewrite it in vertex form and then graph it in the way we already know, or we can use the key information to graph. And I'll show you what I mean by that in a second. Right? So if I rewrite in vertex form, well, all I have to do is find the vertex, right? So x equals negative b over 2a. So x equals 6 over 2 times 3. So 6 over 6, which is 1. So y equals 3 times 1 squared minus 6 times 1 plus 1. So that's 3 minus 6 plus 1. That's negative 3 plus 1, negative 2. So my vertex is 1, negative 2. So in vertex form, 3 times x minus 1 squared minus 2. Write 1 down 2. Write 1 down 2. And then go ahead and make your modified parent function, x, 3x squared, negative 2, negative 1, 0, 1, 2, 0, 3, 3, 4 times 3 is 12. It's not going to quite fit outside of that, but we can do this. Now, to get the exact same thing, all right, find the vertex first, all right? So we found the vertex. And it's 1, -2. Now, I'm going to tell you right now, the y-intercept, one thing I didn't tell you at the beginning of this, I'm going to change colors for a second. C is always the y-intercept, okay? I'm going to ask that question in class. Why is C the y-intercept? So I want you to ponder that. My y-intercept would be 0, 1. So I found my vertex, I found my y-intercept, and using the symmetry of a parabola, I could have gotten this point too. I would know that the point reflected would also be a point. And there you go. I want you to try this last one. All right, so try it out, tell me how it goes, and we'll pick right up there in class. Thanks, guys.